Guys, what's up? I'm back with another tutorial on Python. In this tutorial, we are going to start on object-oriented programming. As the word suggests object-oriented programming, the first word is object. So what is an object? The way of organizing your program, which is to combine data and functionality and wrap it inside something, is called an object. Hence, the programming dealing with object is termed as object-oriented programming. Object-oriented programming, for short, is a programming language which provides a mean of structuring programs so that properties and behaviors are bundled into individual objects. Now to object-oriented programming in Python. Python is a powerful programming language that supports different programming approaches. One of that approach is by creating object, which is known as object-oriented programming. An object has two characteristics. The first one is its attribute and the second one is its behavior. Take an example of a car. A car attribute may include its color, name of the company or model, and its behavior may include driving, stopping, speeding up, etc. The main purpose is actually to create reusable code. Object-oriented programming helps you to create reusable code. This concept basically states that a code should not repeat itself. It will have an object to its location and it will be accessed by using an object for that location. The concept of OOP consists of creating classes, creating instance of a class. Main principle of object-oriented programming may include inheritance and its type, polymorphism, encapsulations, and many others. These all concepts will be explained in the next tutorials. Using an object, you can access a method of a class by creating object of that class. Hence, there is so much for you guys to learn from this section. You do not need to be worried about the programming vocabulary used in this tutorial because all that is going to be covered in this tutorial.
Hey guys, in this video, we will cover classes and objects. So before we move on to making classes and objects, you must know what they are and how they are useful. So this is what we are going to learn in this tutorial. So let's get started. So Python is an object-oriented programming language and a class is a grouping of object-oriented constructs. A class is a code template for creating objects, and object is simply a collection of data and methods that act on those data, and a class is a blueprint for the object. So we can think of a class as a sketch of a house. It contains all the details about the floors, doors, windows. Based on these descriptions, we build the house. A house is an object. As many houses can be made from a description, we can create many objects from a class. An object is also called an instance of a class, and the process of creating this object is called instantiation. Almost everything in Python is an object with its properties and methods. A class is like an object constructor or a blueprint for creating objects. Well, we will cover what constructors are in the coming tutorials. So going in depth, objects are a representation of the real world objects like cars, dogs, bikes, etc. The object share two main characteristics, data and behavior. Cars have data like number of wheels, number of doors, seating capacity, and also have behavior like accelerate, stop, show how much fuel is missing, and so many other things. And a class is a blueprint from which individual objects are created. In the real world, we often find many objects with all the same type, like cars, all the same make and model, have an engine, wheels, doors. Each car was built from the same set of blueprint and has the same components. So in Python, we can create a class using the keyword class. So we type the keyword class and then we can name our class anything we want. So as soon as we define a class, a new class object is created with the same name, this class object will allow us to access different attributes as well as to instantiate new objects of that class. So you can see that we have a class and then we have the class name and then we have the class variable and we named it as x and we put it equal to 25. Now we can access the class variable or function using the object or using the class instance. So in the previous slide, I've told you that if we do not create an object explicitly, Python will create it for us and it will name that object as the class name. So now we can access this class variable using the class name because we haven't created the object explicitly. So basically the class name is now an object, and now with that object we are accessing this variable x. So we type the object name, then dot and x, and it will give us the result 25. Now I will tell you how can we create an object explicitly. So we can create our own class object and name it anything we want. If we don't create an object explicitly, Python will automatically create an object implicitly with the same name as the class name, as I have explained you in the previous slide. So now in this example we have a class and then we have a class variable, and now in this case we are now making an object and naming it as a, and then we are putting it equal to the class name, and now with this object that we have made explicitly, we are accessing this variable x and it is giving us the same result. Multiple objects. Now we can make multiple objects of a single class. Like in this case, we are making two instances or two objects a and b of the same class abc xyz. Now we can either access this variable with either a object or b object. So both will give us the same result. So a.x will give us 34 and b.x will also give us 34 because both are the same instances, both are the instance of the same class abc xyz. Now coming to the advantages of OOP, the first advantage that we have is better productivity, as OOP techniques enforce rules on a programmer that in a long run help her get more work done, finish program work better, have more features, and are easier to read and maintain. OOP programmers take new and existing software objects and stitch them together to make new programs. Because object libraries contain many useful functions, software developers do not have to reinvent the wheel as often. Most of their time goes into making the new program. It is easy to maintain and modify existing code, as new object can be created with small differences to existing ones. In OOP, programmers not only define data types but also deals with operations supplied for data structures. Design benefits. Large programs are very difficult to write. Object-oriented programs force designers to go through an extensive planning phase, which makes for better design with less flaws. In addition, once a program reaches a certain size, object-oriented programs are actually easier to program than non-object-oriented ones. Software maintenance. Programs are not disposable. Legacy code must be dealt with on a daily basis, either to be improved upon or made to work with newer computers and software. And object-oriented programs are much easier to modify and maintain than a non-object oriented programs. So although a lot of work is spent before the program is written, less work is needed to maintain it over time. OOP breaks down your programming solution into small, more manageable chunks. These chunks are rather like Lego bricks. They have a clear interface and you compose a program by snapping these bricks. together. Where appropriate, object can also inherit from other objects, and we will learn how an object can inherit other objects in the coming tutorials, and this leads us to enhance reusability. Inheritance, which is also one of the most important concepts of OOP, and we will cover it in the coming tutorials. However, it's optional and should always be used in a suitable situation, just like composition or aggregation. Well, we will cover all of these concepts in the coming tutorials. So now the last two advantages that we will cover in this tutorial is extensibility and maintainability. So in extensibility, adding new features or responding to changing operating environment can be solved by introducing a few new objects and modifying some existing ones. Maintainability. Objects can be maintained separately, making locating and fixing problems easier. So now in this section, we are going to learn a lot of major concepts of OOP, which is used in 99% of the large application that we make. So now in the next tutorial, we will move on to coding and start making classes and objects. Alright guys, so now you know what classes and objects are and how they are useful. You now also know how can we make classes and objects. Now in this video, we will create classes and then we will make instances or objects of these classes. So we will do some examples and then I will give you an assignment as well. So let's get started. So I've told you, in order to have a class in Python, we use the keyword class to tell Python that we are going to make a class. Next, we name the class. Well, you can name it anything you want, but I'm going to name it as ABCXYZ and then put this colon and hit enter. Now in this class, I will have a variable x and the variable will be equal to 15. Now this variable, which is inside the class, is known as class variable. Now you can print this class variable in this class like print x and run it and it gives you the result 15. Now we will make the instance of this class outside this class. So you can name your instance anything you want, but I'm going to name it as A and put it equal to the class name. Okay, so now we have created an instance A of this class ABCXYZ. Now with this instance, I will access this class variable x. So I will actually print this out. So print the instance name, then dot, and then x. And now if I run it, and it gives you the same result. Now, if I don't create an object explicitly, then Python will create it implicitly and will name it the same as the class name. So now just get rid of the statement, and now we can also access this variable with this class name because Python actually creates an object behind the scene and it named that object as the class name, which is ABCXYZ. So now I can say ABC xyz.x, and now if I run it and it gives you the same result 15. Now I'm going to make a function in this class, so I'm going to name this function as sum. Okay, now remember that the first argument of every class function is always self. Well, what the self is, I have a separate tutorial on this parameter self, but for now just know that the first parameter of the class function is always self. Now this function will have two variables, a and then second variable, let's say 9, and this function will print the sum of these two numbers. Now I can call it using the class name, or I can create the instance of this class, and then with that instance I will actually call this method. So a dot sum. And now if I run it, it prints out the sum of these two numbers. Okay, now we can create multiple objects of a single class. Like I have this instance A, I can create another instance of the same class like B equal to abcxyz, and now I can either call this function sum either with this instance or this instance. So let's say that I call it with both instances. So this thing, and now if I run it, so first of all it calls this method with instance A and gives the result 13, and then it calls the same function with this instance B and gives the result 13. So now there are many advantages of creating multiple instances of the same class that you will come to know in the future tutorials. So I think that is all that I need to teach you for this tutorial. In the next tutorial, I will teach you what is the difference between a class function and a non-class function. Hello guys, and in this video you will learn the differences between Python function and Python method. So first of all, we will cover Python method. So a Python method is like a function except it is attached to an object. A method is a part of a class. A method is a piece of code that is called by a name that is associated with an object. In most respects, it is identical to a function except for two key differences. It is implicitly passed for the object for which it was called, and it is able to operate on data that is contained within the class. Remembering that an object is an instance of a class, the class is the definition while the object is an instance of that data. When Python dispatches a method, then it binds the first parameter of that call to the appropriate object reference, which is actually self. Well, you will learn about the self parameter later on in this section. So in short, we can say that a method always resides inside the class and is called via an object, and to call the method, we need to instantiate an object. Python method is like a function except it is attached to an object. We call a method on an object and it possibly makes changes to that object. A method then belongs to a class. So a method is a function which defines some characteristics on an object. You may say class. A method is embedded in the object and it works for the object. Now we will cover what is a Python function. So a Python function, on the other hand, is not associated with the object instances or classes, which means that a function is defined outside of a class. A function is a code fragment in which you pass arguments and call it to operate some mathematical logical operations and then return or not the result of the operation. So function is simply a piece of code that is called by name. It can be passed data to operate on, that is the parameter, and can optionally return data. All data that is passed to a function is explicitly passed. When we talk about Python functions, we talked about built-in functions and user-defined functions. And you already know the difference between user-defined functions and built-in functions. So the key points of functions are that the functions can have different parameters or may not have any at all. If any data are passed, they are passed explicitly. It may or may not return any data. And function does not deal with classes and its instance concept. So in the end, we conclude that there is a thin difference between method and function in Python. The only major difference is that we call Python method on an object, but it's not the same with functions. Also, methods may modify an object while Python function don't. So this is an example of a Python method in which we have a class ABC, and then inside this class we have a function named Bilal, and it is printing out something on the console screen. And now in order to call this function Bilal, which is actually inside the class ABC, we need to create its instance, and then we will bind this method with this instance A, and then we can call this method. So you can see that this function, which is actually a method because it is inside the class and is associated with an object. Now this is an example of a function in which we have a function, and this is printing out something on the console screen, and we are simply calling it with its name.
Hey guys, what's up? And I'm back with another tutorial on Python. And in this tutorial, we will study more about objects. In Python, everything you do is an object. Whether you initialize an integer, whether you initialize a string, whether you initialize a float, or whether you make a function or enter a number directly. Every initialization and declaration is an object in Python. In simple words, everything is an object in Python. Let me show you this with the help of some examples. So I will just move on to PyCharm, and in here I'm going to initialize first an integer, then b equals to a float, and c is going to be equal to a string, let's say my name, and then I'm going to print out type of all of these. This is a built-in function which is type, that's going to print out the type of whatever we specified in the round braces. In this I've specified a, this is going to give us the type of this a, whatever is the type of this a. So I'm also going to print out the type of b, and also I'm going to print out the type of c. So if I just run it now, it says class int, class float, class string. Now what does that mean? This means that this int, which is this a equals to 3, which you already know that it is an integer, but this integer is extracted from a class which object is int that gives us a reference to initialize this integer right here in our code. The second one is a float, which means that this is a float object that helps us initialize this float over here, and this str means string, and it helps us write my name over here, and when I printed out their types, it all give us to be object. This means that everything you do in Python, everything you do is an object. You can also get the type of a function, you can also get a type of a direct value, you can get the type of anything, and you are going to get this class word and then the type. So let me just do one more thing, and then I'm going to end up. If I write in type 3, which means that I want to know a number directly without specifying it in sub braces or whatever, it also give me int, which means that 3 is an integer, and it is also extracted from a built-in class that has an int object that gives us a reference and allow us to initialize this integer right here in our code.
Hey guys, and in this video you will learn about the initializer method in Python. Well, if you know C++ or Java, then this method is also known as constructor method. So an initializer method, or you can say a constructor, is a special kind of method that Python calls when it instantiates an object using the definitions found in your class. Python relies on the constructor to perform tasks such as initializing, that is, assigning values to any instance variable that the object will need when it starts. Constructors can also verify that there are enough resources for the object and perform any other startup task that you can think of. So the name of a constructor is always the same, that is init. The constructor can accept arguments when necessary to create the object. When you create a class without a constructor, Python automatically creates a default constructor for you that doesn't do anything. Every class must have a constructor, even if it simply relies on the default constructor. So a Python class constructor is the first piece of code to be executed when you create a new object of a class. So as soon as you create a new object, the constructor method is called. And the constructor method can be used to put values in the member variables. You may also print messages in the constructor to be confirmed whether the object has been created or not. So now let's do an example. So for this, just minimize the slides and open your PyCharm. So first of all, I'm going to make a class and I'm going to name it as ABC or XYZ. And now in this class, I'm going to make the initializer method or a constructor. So we type here def like we do while making functions, and then the name of this initializer function is __ init, and then _ once again, and then obviously the self argument. Now let's say that this constructor method will print something out on the console screen like the object has been successfully created. Now I'm going to make an instance of this class. So I'm going to name this instance as A and put it equal to XYZ. Now as soon as I create an instance, basically this method gets called and this will print out this thing out on the console screen. So basically as soon as you create an object, the initializer function, or you can say a constructor, gets called. So now when I run it, it should print this thing out on the console screen. So run and see that we have this thing out on the console screen. Now we can pass arguments like we pass arguments to a function. So let's say that we pass some kind of string, and the string is the object has been created successfully. And now this argument will be passed in, let's say, a variable known as object. And now since I have passed this string to this parameter object, so now I can print out this thing. So print object, and now when I run it, I will have the same output, and yes, I have the same output. So basically as soon as you create an object, the initializer function gets called and it executes whatever is inside it. So even if you don't create this initializer function, Python will automatically call it, but it will then do nothing. But we can make initializer function to do things like initializing variables and object creations, and we can verify that our object has been created successfully or not. So this is all I need to teach you about the constructor method, or you can say initializer method. Hey guys, in this video we will learn about modules in Python and how they are useful. Modules refer to a file containing Python statements and definitions. A file containing Python code, for example abc.py, is called a module, and its module name would be abc. So we use the modules to break down large programs into small, manageable and organized files. Furthermore, modules provide reusability of code. We can define our most used functions in a module and import it instead of copying their definitions into different programs. Modules enable us to split parts of our program in different files for easier maintenance and better performance. As a beginner, you start working with Python on the interpreter. Later, when you need to write longer programs, you start writing scripts. And as your program grows bigger and bigger, you want to split it into several files for easier maintenance as well as reusability of the code. The solution to this is modules. You can define your most used functions in a module and import it instead of copying their definitions into different programs. A module can be imported by another program to make use of its functionality. This is how you can use the Python standard library as well. Now, to use the functionality present in any module, you have to use the keyword import in your current program. You need to use the import keyword along with the desired module name. When interpreter comes across an import statement, it imports the module to your current program. You can then use the function inside a module using a dot operator along with the module name. First, let's see how to use the standard library modules. So in the example below, math module is imported into the program so that you can use the square root function defined in it. So basically we import math. Well, it is missing here, but assume that we have import math, and next we have a variable which is equal to 4, and now with this module which is missing, which is actually math, we are calling a function which is inside the math module, which is known as square root, and then in the function we are passing this variable, and then that function will return the square root of this number 4. So we can use the dot operator to access the square root inside the module math. So now let's say that we have a module abc.py and it contains two methods. So assume that this is a module and we named it as abc.py and it contains two methods, sum and multiply. Now I have another module xyz.py which import the abc.py module. So basically we are importing the abc module that we have created right here, and then with this module name that we have imported, we are calling the sum and multiply function that we have defined here, and then these functions are returning the result right here. Now there are more ways to import modules. So we can import some specific statement from the module, some specific functions or variables from the module, or we can import everything from the module, and we can rename our module as well. We can only rename our imported module. So first we will look how can we import specific things from the module. So this statement, which is basically from module name, import the variable or function that we want to import, allows you to import specific function variables from a module instead of importing everything. So in the previous example, when you imported abc into the module xyz.py, both the add and multiply functions were imported. But what if you only need the add function in your code? Then we will actually use this statement. So here is what you need to do. We can say from abc import add. Now we are actually importing the add function from the abc module. So we are saying from the abc module import only the add function. Now we can only use the add function in the xyz module. So actually we are now calling the add function from the abc module, and it is returning the result 2 plus 3 which is equal to 5. So in the above example, only the add function is imported and used. Notice the use of add. You can now access it directly without using the module name. You can import multiple attributes as well, separating them with a comma in the import statement. Like in here, we can type from abc import add, then comma multiply, comma subtraction, comma division, and so on. And notice that by importing very specific function, we only now need the name of this function, or we can say variable, to access that variable from that module abc. Next we have another from statement, and this is basically used, and the static basically indicates that we are actually importing everything from the module. So you can import all attributes of a module using the statement right here. So this will make all attributes of imported module visible in your code. So here is an example to illustrate the use of the statement. So now here we are saying from ABC, so from the ABC module import static. So static means import everything from this module ABC, and now we can use both of these functions in the module XYZ. So note that in the professional world you should avoid using the from import, or you can say from import everything, as it makes your code less readable. Now we will learn how can we basically rename the imported module. Well, you can rename the module you are importing, which can be useful in cases when you want to give a more meaningful name to the module, or the module name is too large to use repeatedly. So you can use the keyword as to rename it. So the following example explains how to use it in your program. So now we are basically importing the ABC module, and we will now use that module as A. So now this module in the imported class is now equal to A, and now we can actually call the add function using this A. Actually, I've got a mistake here. This should be A instead of CAL. So I can simply say A.add, and it will give me the result instead of typing ABC. So you save yourself some typing by renaming ABC as A. And note that you now cannot use the abc.add anymore, because we have told Python that we will actually be using this ABC module as A, as calculation is no longer recognized in your program. Now there are some advantages of modular programming. So modular programming basically refers to the process of breaking a large, unwieldy programming task into separate, smaller, more manageable subtasks or modules. Individual modules can then be cobbled together like building blocks to create a large application. There are several advantages to modularizing code in a large application. So the first thing we have is simplicity. Rather than focusing on the entire problem at hand, a module typically focuses on one relatively small portion of the problem. If you are working on a single module, you will have a smaller problem domain to wrap your head around. This makes development easier and less error prone. The next advantage that we have is maintainability. Modules are typically designed so that they enforce logical boundaries between different problems domain. If modules are written in a way that minimizes interdependencies, there is decreased likelihood that modification to a single module will have an impact on the other parts of the program. Well, you may even be able to make changes to a module without having any knowledge of the application outside that module. So this makes it more viable for a team of many programmers to work collaboratively on a large application. So the next advantage that we have is reusability, and I think that we have covered it in the starting slides. Well, functionality defined in a single module can be easily reused by simply importing it, obviously, through an appropriate defined interface by other parts of the application. This eliminates the need of recreate duplicate code. Scoping. Modules typically define a separate namespaces, which helps avoid collision between identifiers in different areas of a program. So now finally, let's move on to coding so that you can understand it practically as well. So now open your PyCharm, and now in here I'm going to create a new file, and it will be a Python file, and I'm going to name it as abc.py. So now click OK. Okay, now in this module abc.py, I will create two functions, add and multiply. So def add, and it will take two arguments a and b, and it would return the sum of these two numbers. Now similarly, I will have one more function, multiply, and then it will also take two arguments and it will return the result after multiplying them. So return A multiplied by B, and then I will have one more function of, let's say, division and B, and it will return the result A divided by B. Now finally I will have one more function of, let's say, subtraction, and it will also take two arguments and it will subtract two numbers, so A minus B. I'm missing this colon here, here, and here. Okay, now I'm going to create one more module. So Python file, and I'm going to name this module as xyz dot py, and now hit OK. And now what I'm going to do is that I will import this module abc.py. So type import abc, and now remember that not to type the extension .py while importing the module. So now I can say simply, and now I can actually use these functions once I've imported this module. So I can now say print abc, which is the module that I've imported, and then I can call the add function, and let's say that it will be 3 and 4. Now I'm going to use one more function from the imported module, and it will be, let's say, multiply, and it's 4 and 3. So now when I run this xyz module, so run, and it is xyz, and I'm getting an error, attribute error, module abc has no attribute, abc need down. And the reason I'm getting this error is because this abc.py module is a built-in module, and we cannot name our own module the same as built-in modules. So actually we need to actually rename it, or we can actually delete it. So just copy everything from here, and now we will delete this module. So right here where it is, now we will delete it. So delete, click OK, and now I will create a new module, and I'm going to name it as abcd, and now hit OK. Did not get file in this. Okay, so I'm going to name it as abcde, and now hit OK. And now when I paste the previous code, and now in here we will import abce, and now everything should work fine. Right here abcde. So actually now everything is fine. So basically in this module xyz.py we are importing the abcde module, and then we are actually using this function in this module xyz by importing this module. So I think I can now run it, and now you can see that the error is gone, and it is giving me the result 3 plus 4 7, and 4 multiplied by 3 is equal to 12. Now I can make use of the now I can be importing only, let's say, the division module from the abcde module. So I can type from abcde import the module only division, and now in here I need to get rid of this, and this, and now in here I can type division, and then I need to pass two arguments. Let's say it is 6 and 2, and now when I run it, And now notice that I can only use the division function from this module ABCDE because I have only imported the division method from the ABCDE module. So now when I run it, it will give the result 3.0. Now similarly, I can import everything from the ABCDE module by typing here static, and now I can, let's say, print use the subtract method. So it is, let's say, 5 and 4. So now when I run it, so you can see that now I can use any method which is in the ABCDE module by importing everything from the module ABCDE using this static symbol. Now I'm going to tell you that how basically we can rename or import the imported module. So I can say import ABCDE as, let's say, A, and now I can call this method by using a.division. So 6 and 2, and now similarly a dot sub, let's say, and it is also 6 and 2. So now when I run it, and it is giving me some output. So basically, and now I have told you in the slide that I now cannot use the ABCDE module to call this method because I have told here Python that I will use this module ABCDE as A in my code. So if I type here ABCDE dot division, and now when I run it, it will throw an error which is name error because it does not know about this module ABCDE, because we have told Python to use this module ABCDE as A. So now in the future we can only refer to this module function as A. So now it will work fine. So I think that you now understand what basically modules are and how they are useful, and that was the purpose of the tutorial.
Hey guys, what's up? I'm back with another tutorial on Python. In this tutorial and a couple of tutorials ahead, we will be covering inheritance and the types of inheritance we can use in Python that include multiple inheritance, multi-level inheritance, hybrid inheritance, and hierarchical inheritance. For this tutorial, we limit ourselves to only inheritance. So what is inheritance? The word inheritance means heritage or legacy. To explain inheritance, let me give you an example. You know that the property of your father is transferred to you, so that property is inherited actually to you from your father. In computer programming, inheritance enables us to define a class that take all the functionality from the parent class and allow us to make certain modifications to it or leave it as so. It refers to define a new class called the derived or child class that inherit all the functions and variables from the base or parent class. So let me give you an example to show you that how this works. So I'll just move on to PyCharm, and here I will define a class that is going to be named parent. So this is the parent class. In this parent class, the first thing we need to do is that we need to define a constructor function. That is going to be def init. It's going to take itself, and this is going to print out calling parent constructor. Good enough. So the next thing we need to do is that we need to define a method over here that is going to be named as parent method, and this parent method is going to simply print out calling parent method. So whenever this method is called, this is going to print out calling print method. So the next thing is that we need to define a child class now. Now, how is a child class defined? For this, you need to specify the name of the class, and in the brackets, you want to write the name of the class from which you want to derive that class. So I want to derive it from parent. So in here, we are also going to have a constructor. And in that constructor, we are going to print out calling child constructor. Alright, and the next thing we need to do is that we need to define a function for this class as well, that's going to be named as child method, and this child method is going to have a print statement that's going to print out calling child method. Good enough. So seem to have an error. Good enough. Now what we need to do is that first let me explain you here something. We need no errors. Alright. So no errors now. So yes. So now what we need to do. Now you can see over here that this child class is inherited from this parent class. This means that this class, this child class over here, also have a function now named as parent method. But this parent method does not have this class name, this method named child method, because the child know the properties of its parents, but the parent does not know the properties of its child. Nor does it know that how many child it has, but a child know that it has this as a parent, and this has this, his parent contain this function named parent method, and this parent method can be accessed using the object of this class named child class. So let me just demonstrate how we can now call these classes. So we will define an object name, let's say P for parent, and we are going to have equals to parent, and we are going to have an object for child class that's going to be C. So these are the two objects for parent and child classes. Now if I type in P dot parent method and type in C dot child method, alright, and now I just run it. We've got errors here. Alright, we have this dot extra over here. Alright, good enough. Let me run it now, and it ran perfectly. And the first thing that was printed was calling parent method, because we called parent method first, and this parent method was called, and this calling print method was printed out, and then we have called the child method, and calling child method was printed. Now to the concept of inheritance. Inheritance helps us to call the methods that are included in this parent class using the object of this child class, because this child class has inherited all the properties from this parent class, and now can call, for example, if I type in C dot parent method, and it's going to run perfectly. I just run it. It says calling parent method. This means that this object C, that is the object of the child class, has called a method of the parent class, because this child class contains this method that was from the parent class, because it has inherited that class. Now if I type in P dot child method and just run it, we are going to have errors in line number 23. This is because, as I told you earlier, that this parent does not know this parent does not know that its child exists. So it does not know that it have a method named child method. because it does not know its properties, but this child method knows its properties. Hence, when we use this over here, c.parent method, it executed perfectly, but when I use p.child method, it doesn't work. So hope that you are now clear with the concept of inheritance, that what is inheritance and how can we use the object of a child class to call a method that is present in the parent class, and how a child class inherit the properties and methods of a parent class. So you can also do one thing more: method overriding. Method overriding can also be done if you want certain methods to change while certain to not. So let me give you an example. For example, we have one more method over here, that is, let's say, def parent method next. This is the next parent method, and in here we are going to simply print out next method. Alright, so now you know that this child class has inherited all the properties. So this child class now has two methods extra, the parent method next and the parent method. So now if I call out c.parent method next and just run it. First we need to remove this thing from here, not this thing. So when I run 923, I think I've misspelled it. Alright, let me just copy this and paste it over here because I have misspelled the spelling of parent method. Alright, good enough. So let me just run it now, and it says next method. So now this child class has two extra methods, the parent method and the parent method next. So now what if I want to change something from this method but not this method, and I have inherited this class and this class contain both these methods. Now if I want some changing in this method but not in this method because they are itself copied in this child class, so I will just create this method in the child class. What I want to say is, let me show you. If I type in parent MEHDOD, I've misspelled it, and type in print parent method changed success. Alright, so now if I just run it, it's going to say parent method changed success, because now it has called this method, not this method over here. So you have understood this concept, I hope. What I want to say is that when two methods are copied in here in the child class, for example 100 of methods are copied in this child class, and you have inherited that child class, but you want only one method to change its property and one method to change its functionality, then you can create that function in the child class and do whatever you want to do with that function. Hey guys, what's up, and I welcome you to another tutorial on inheritance in Python. In this tutorial we are going to be covering hierarchical inheritance. The first thing you need to know is that what is a hierarchy. Hierarchy is actually like a tree. It has a parent node and then children or leaves that are attached with the branches of the tree. So hierarchical inheritance is when more than one class inherited from a same class. So let me show you this with the help of an example. So I will move on to PyCharm, and in PyCharm I'm going to initialize a class parent, and that parent class is going to have a function that is going to be the initializer function, and that initializer function is going to simply print out a, and then we are going to have another method named as parent method, and that parent method is going to print out parent method, and then we are going to have another class named child, and that child class is going to also have an initializer constructor function, and that's going to print out hi. And then we are going to have a method named child method, and that child method is going to simply print out child method. And now we need to derive it as well, so I will just put in brackets here and put on this parent over here. So now I will define another class named more childs. This more child is also going to be derived from parent, which makes it hierarchical inheritance, and this is going to contain two functions. The first one is going to be the initializer constructor function that is going to print out hello. Since that's the only left one, it's going to have these columns as well. This does not need columns. And one more, let's make a child's method, an additional s to distinguish it from the above method, and it's going to print out more child method. So good enough. So now I'm going to create objects, but before creating objects, I'm going to show you that how this is hierarchical inheritance. You can see that this is a parent class, so we will have a node right over here, and this parent class is then derived into two classes over here and over here, and these are at the same level. The first one is the child class that is inherited from the parent class, and it has all the functionality that the parent class has. And then we have class named more child that is also inherited from this parent class, and it has the entire functionality of this parent class. So now let me define objects for these all classes. So the first one is going to be P, that stands for parent. The second one is going to be C, that's going to stand for child. And the third one is going to be M, that stands for more child. Good enough. It's going to be more childs. So now we are going to call functions for them. So the first one is going to be p dot parent method. The second one is going to be c dot child method, and the last one is going to be m dot child's method. So I hope I've spelled them correct. First one is child, M-E-H-D-O-D, right, and the second one is M-E-H-D-O-D. I don't know why I misspelled it always. So they are now corrected. I'm just going to run it, and I have an error in line 15. What was line 15? Yes, we have a column missing over here. So let me just run it again, and it says parent method, child method, and more child method. So now let me show you an example how both these classes have the entire methods that are in the parent method. So if I call this parent method using the child object, as well as I just copy this statement, paste it over here, and call it using the more child class. Since both these classes are inherited from this parent class, and I've called a method of the parent class using the objects of these child classes. So if I just run it now, it says parent method, because both these classes have the functionality of the parent method, and it has the methods that are present in the parent method. So hope you're clear about this concept, that what is hierarchical inheritance. Hey guys, what's up, and welcome to another tutorial on inheritance. In this tutorial we will be covering multi-level inheritance. So what is multi-level inheritance? If a class is derived from a derived class, then this is called multi-level inheritance. In simple words, if you inherit a class that is already a child class for some other parent class, then this concept in programming is called multi-level inheritance. This is such a simple concept. It is almost the same as multiple inheritance, with the basic difference that in multiple inheritance, two classes are derived from a single class, and in multi-level inheritance, the class is derived into two levels. So enough of talking, let me show you an example to clear your concepts. So I will just move on to PyCharm, and in here I'm going to initialize a class named parent, and this parent class is going to have an initializer function that is also known as the constructor function for that class, and that constructor function is going to simply print out I am parent constructor. Alright, so the next thing we need to do is that also we need to have a method over here. So we are going to have a method named parent method, and this parent method is going to print out I am parent method. Alright, good enough with this class. So the second class we need to identify is going to be the child class that is going to be inherited from the parent class, and this is going to have also two methods. The first is going to be the constructor, and the constructor is going to just print out I am the child constructor, and the next method in this is going to be child method, and this child method is simply going to print out I am the child method. So the next class is going to be next child, and this is going to be inherited from the child class, and it is going to have a constructor initializer that is going to print out I am the child's child constructor. I'm the child's child constructor. Don't bother the spellings. And it's also going to have a method name next child, and this next child is going to print out I am the child of child method. Don't know what I'm talking about. Don't know what I'm typing, but it is so. So let me now just create objects for all of these classes. But before creating the objects, let me show you how this is multi-level inheritance. You can see that we have a parent class right over here, a child class, a class named child inherit this parent class, and then we have a class named next child that inherit this child class that is already inherited from this parent class. So this is a multi-level inheritance. So now let me just create objects for these. The first one is going to be P, that is going to be equal to parent. The second one is going to be C, that is going to be equal to child, and the third one is going to be N, that is going to be equal to next child. Good enough. So now we are going to call out P dot parent method, C dot child method, and N dot next child. So when I will run this, alright, we have an error in line number 26. I think we have some errors with the spellings. parent method. Alright, we got it. It's parent method. So let me just run it now. So it says I am parent method, it says I am child method, and it says I am the child or child method. So now, one more important thing I must say. Now that we know that this is a child class that is inherited from this parent class, and this child class contains this method named parent method. But in multi-level inheritance, this class that is the last child in the hierarchical tree, this next child class not only contain this child method from which it is extended, but it also contains this parent method, because this parent method has given its method to this child class, because this child class has inherited this parent method and it has the parent method. So when this next child class inherits this child class, it not only inherits this child method but also this parent method. Let me call this using the object of the next child. So I will just replace it here. I'm going to call out n.parent method, and I'm going to call out n.child method. So if I just run it now, I have the same output using the object of the next child, because this next child contains this child method as well as this parent method. And why? I've explained it to you, because this parent method is present in this child method, because this child class has inherited this parent class, and now this child class has both the methods, and this next child has inherited this child class, so it will have both the methods, the parent method and the child method as well. So when I initialize its object as n over here and call the parent method as well as the child method using this object n, I get the same output, because I have accessed the parent method as well as the child method as well as the next child method. So this is multi-level inheritance in Python. So I hope you have cleared your concepts about these. An important note: you need to very well understand the difference between the types of inheritance we are covering up till now, whether it be multiple inheritance, multi-level inheritance, or the types of inheritance we will cover in the future. You need to get a good grip on these, else you will not be able to implement them usefully. So go through the slides, go through the videos again and again until you are sure that yes, I got it. Hey guys, what's up? And I'm back with another tutorial on inheritance in Python. So the next and maybe the last type of inheritance we are going to cover in this inheritance section is the hybrid inheritance, which we'll be covering in this tutorial. Hybrid is actually a thing made by the combination of two different elements. Now what are those two different elements that make up hybrid, a type of inheritance? So those two types are multi-level inheritance and multiple inheritance. This means that a program having multiple inheritance as well as multiple inheritance is known as a hybrid inheritance program. So let me give you an example to show how hybrid inheritance is done. So I will just move on to PyCharm, and in PyCharm I'm going to have a class named parent, and this parent class I'm first going to have an initializer function. You might have noticed that I do not often use this initializer function, but this is a very important programming technique and a programming practice, and a good programming practice I must say, to always define this initializer function, because this is a constructor and this must be initialized. So in this constructor function I'm going to simply print out constructor, nothing else. So the next thing we need to do is that I want to have a method named parent method, and this parent method is going to print out parent method, and the next class we are going to have is going to be the class named child, It is going to be inherited from the parent class, and this is going to have an initializer constructor function, and this constructor function is going to print out the very same. It's going to just print out constructor. The next function this child class is going to have is the child method, and this class is going to print out child method. Alright, so the next class we need to have is the next child. And this is going to be extracted from the parent class, and it's going to have a constructor init function. That is going to print out constructor init. Badly misspelled it doesn't matter. And we are going to have a next child method as well. The next child method is going to print out next child method. Let me just correct the spelling of this, since it's going to create problems when we are going to call it. So this, as you can see, is that this is multiple inheritance so far. So this means that we have achieved one level, or you may say one module of a hybrid inheritance, that we have achieved multiple inheritance in our program. But to achieve a complete hybrid inheritance and to call it a program of hybrid inheritance, we also need multi-level inheritance in this. So we are going to create one more class that is going to have multiple inheritance, and is going to, let's call it multiple, and this class is going to extract the child class, comma, the next child class as well. And this is going to have an initializer constructor function as well, and this initializer constructor function is going to simply print out constructor. I've been very bad at typing constructor. Alright, so the next method it's going to have is multiple method, and this multiple method is going to print out multiple method. Alright, multiple method, I think. Alright, doesn't matter with the spelling, so good enough. So now you can see that we have a class named parent, from which two classes are extending. We have two classes that are extending a parent class, or a parent class that extending to child classes, and these two child classes are then extracted from this multiple class named multiple. This makes it multi-level inheritance, because we have a level like this, and then we have got two levels like this, and then a level like this. You've seen that picture of a diamond or a D in the multi-level inheritance program, and you know that was also complexity level, and I explained the complexity level in the multi-level inheritance. This is the same, this is going to form the same hierarchical diagram. So this is now hybrid inheritance, because we have multi-level inheritance. You can see over here that we have multi-level inheritance over here, and as well we have also multiple inheritance right over here. So hope you have got the concept, and you already know that how methods and so you already know that how methods are extended in this type of programs when I explained that diamond level complexity issues to you. So these are going to be called in the very same way, and if you change one of them and do not change the other of them, you've seen all of those scenarios in the break. If you don't understand what I'm talking about, go to the multi-level inheritance tutorial and go through it again to see how all of these classes are going to be called, and how these are extended from each other, and how making a change in one affects the other, or all the scenarios you can see in the multi-level inheritance topic. Hey guys, what's up? And I welcome you to another tutorial on Python. In this tutorial, we will be covering a very new concept named method overloading. Defining a method with the same name but changing the number of arguments that function can be called with is called method overloading. For example, we have a function named run. We can now call this function using 0 arguments, 1 arguments, 2 arguments, 3 arguments, or whatever number of arguments we like. For example, we have a function named run. Now we can call this function using 0, 1, 2, 3 and whatever number of arguments we like. So let me just give you a quick example to show what is method overriding and how it is done in Python. So I will initialize a class name, let's say overloading, since I'm explaining overloading in this. And this is first going to have an initializer function. And it's going to print out constructor. You know what is the purpose of the constructor? It's used for initializations. So the next thing we need to do is that I will define a function named run, and this run is going to, for example, have an argument named as name, and we are going to set it to none. Now what does this none mean? This none means that if we pass something to this as an argument, then it's going to receive that and use it as an argument. But if we pass nothing to this function and we pass no argument to this function, then it doesn't matter at all. So it's going to simply print out, but let me specify some conditions over here. It's going to say that if name equals to none, then it's going to print out I received nothing. Else if it receives something, it's going to print out I received some arguments. Alright, so let's end this class and call over here. Alright, so let's define an object named O for that overloading class up there. And we are now going to call O.run. So we have passed no arguments, and if I just run it now, it says I received nothing. And if I just pass on now something, let's say var to it, and now run it, it says I received some arguments. So when we type in name equals to none, you have seen the default values for arguments. So if we set the default value for an argument as none, then it doesn't matter if we pass something to it or if we don't. If we pass something to it, it's going to use it, and if nothing is passed to that function, that function barely ignores that argument. So when we call it using nothing, it says I received nothing because we passed nothing to it, and if when we pass something, it says I received some argument. You can change the number of that. For example, you can type in like age equals to none. So we can type in the number of arguments we want. So I hope you're clear about this concept. So in the next tutorial, maybe we'll be covering much more interesting stuff like that as well.
Hey guys, what's up? And I'm back with another tutorial on Python. In this tutorial, we will be covering operator overloading. You now at least know that what is overloading. A single thing doing different jobs is actually called overloading in the language of computer programming. So operator overloading is a specific case of polymorphism in which operators are treated as polymorph functions and as such have different behaviors depending on the type of arguments. For example, you have seen the case of plus operator. It add numbers as well as it's concat two strings. Hence, if we use the plus operator for integers or float values without quotation marks, then it will add those two numbers and if we specify string in quotation marks and apply the plus operator on it, then it will concat those two strings. Let me show you how this is done. So I will just move on to PyCharm, and in here if I initialize two variables, a equals to 2 and b equals to 3 and c equals to a plus b, and if I just print out this c and run this code, so now the plus operator has act like an addition operator and has added those two numbers and give me a 5. Now if I just change this and make d equals to a string, let's say Omer, and e equals to another string that is going to have Khan. So now if I have another value and I concat these two numbers d plus e, and if I just now print out this f right over here and just run this code, it says Omer Khan. So for the first thing it has added these two numbers, and for the second case the plus operator has concat these two strings together. This means that the plus operator is overloaded and it will perform the functionality we want it to perform. So now to a complex example to show you how operator overloading works. So I will just remove all this. So now I will use the plus operator to add two objects, and I will show you this by calculating the area of a circle. So I will make a class named circle, and in that class we will have an initializer constructor function, and in that constructor function we are going to receive one argument that is going to be the radius. We are going to initialize this radius using this constructor function for this class called circle. So in here we are going to write in self dot radius equals to radius. Good enough. So now moving on to the next function is we are going to set the radius. The second function is going to be set radius, and this set radius function is also going to set the radius for us, and that's called self dot radius equals to radius. Right, we need an argument over here as well, radius. Alright, so the next function is going to be the get radius function, and in this get radius function we are going to receive no argument, and in this we are going to only return whatever radius we have now. So we are going to write out self dot radius. Alright, now so the next function is going to be the area function that is going to calculate the area for us, and it's going to receive nothing, and this is going to simply return mat.py. That stands for, since the formula for calculating the area of a circle is pi r square, so we need a pi, then we need the radius over here, and then we need pi r, and then we need a square, so we are going to write out 2 over here. So good enough. So one more thing, we need to import the math class over here since we are using the pi function over here. So we are going to import math. Alright, so here we have now. So now the next thing we need to do is that we need to have a function that is going to add those two areas together. So I will just create a function named add, and in that function add we are going to receive another. Now what is that another? I will show you what is this another. So in this we are going to return and it's going to have self dot radius plus another dot radius. So this another is actually the radius that is going to be used for the other object that is going to add the second object that is going to be passed to this function. So the next thing we need to do is that we need to create objects for this. So the first object is going to be C1 and it is going to be passed to circle class. Alright, so we have this error over here since C need to be in capital, since Python is case sensitive as I told you earlier. So it is going to be circle and we are going to pass out radius as 6, let's say, and we are going to simply print out C1 dot get radius. Alright, good enough. So we have this error over here. What is the problem with this? We need to add this object right over here, self dot radius. Yeah, that makes it cool. So let me just run it now, and it says 5 because we have only called the get radius function, and this get radius function has returned whatever we passed on. So now this object references to 5. So now we are going to initialize one more object named circle, and in here we are going to pass, let's say, 6, and we are going to print out C2 dot get radius, and we are going to run it again and return us 5 and 6. Now C1 contains 5 and C2. So now I'm going to add these two objects in an other object named C3, and I'm going to add C1 plus C2, and now I'm going to call the get radius function using this C3. So I'm going to call out get radius using C3. I'm going to type out C3.getRadius, and it's good enough. So I'll just run it now, and it says 11. It has added the result of these two objects. This means that the plus operator is overloaded, and it can not only add to integers, to floats, and it can not only concat to string, but it can also add to objects, since the plus operator is overloaded in Python, and this is known as operator overloading in Python.
Hey guys, and in this video I will teach you about encapsulation and different types of access modifiers. Now, encapsulation means hiding some kind of important data and providing some kind of security to it. So basically, you can restrict access to variables and methods so that it cannot be modified unintentionally or accidentally. Now, there are two types of encapsulations in Python, public and private. So all the methods we have made so far are public. Now, in order to make a private method or private variable, you need to put two underscore right before the variable or method name. So now let's create a class of courses. So class courses, and this class will contain a public variable name student, and this will be equal to, let's say, 55, and a private method and a private variable as well. Now, in order to make a private variable, you need to put two underscore and then the name of the variable. So let's say that it is username and it is equal to Udemy29, and now this class will contain a public method as well. So def student strength, and this method will print something out on the console screen. So we can print this is a public method, and now I will have one private method as well. So def, and now these two underscore to indicate that this is a private method. So I'm going to name this method as student username, and now I will print this is a private method. Okay, now this private variable and this private method can only be accessed within this class. It cannot be accessed outside the class. So now let's make a new class in the same module, and I'm going to name this class as test. And now we will make the instance of this class courses. So just name this instance. So name the instance anything you want and put it equal to courses. And now if I access the public method, so it is student strength, you can see that we do not have any to underscore right before this method name. It means that it is a public method and we can access it, outside the class. So now when I run it, you can see that it is accessing this method student strength and printing this thing out on the console screen. Now I can also access the private variable student, and now when I run it, you can see that it is accessing this variable. So now let's print out this thing, print, and now run it again. So see that it is accessing this public variable. If I try to access private method or variable, let's see what error it will give me. So a dot underscore, what I have named it is std username. And now when I run it, it will give me the error. It shows me the error, attribute error, courses object has no attribute, this thing, because it does not know anything about this method as it is kept private. In order to access private method in another class, we first make the instance like we have made right here, and then with this instance name we first call the class name with the underscore. So the name of the class is courses. So see that we have put this underscore, and then right after the underscore type dot, and then the private method which is std username. And now when I run it, and it is still giving me an error. So let's see what it is. I think that I don't need to put this dot here, and now when I run it, so now see that it is accessing the private method as well. So now in order to access private method, we first create the instance of that class in which that private method resides, and then I type the class name, but before the class name I type this underscore, and then without having any dot I type the name of the method. Now we can access private variables in much the same way. So just remove it and type the name of the private method that you want to access. So in this case it is user name. So I think I need to print out. So print, and now run it. So you can see that it is accessing the private variable as well. So this is how we can create private variables and private methods, and you have learned how basically we can access it in Python. Hey guys, and in this video you will learn about one of the most important concepts of object-oriented programming, and it's known as polymorphism. So you will learn about polymorphism in Python and how it is useful in this video. So in Python, polymorphism is the ability of multiple different objects derived from different classes to be used in the same way. Polymorphism is the ability of an object to take on many forms. Polymorphism in general sense refers to the property of an object being capable of existing in several different shapes or forms. In Python, polymorphism refers to different classes having methods by the same name, but these methods have the same functionality achieved differently. Now, particular behavior may be realized differently by objects of different classes, these classes are said to have the same interface owing to the same name of the methods. Now for object-oriented programming in Python, this means that a particular object belonging to a particular class can be used in the same way as it were a different object belonging to a different class. Polymorphism allows for flexibility and loose coupling so that code can be extended and easily maintained over time. Polymorphism is an important feature of class definition in Python that is utilized when you have commonly named methods across classes or subclasses. This allows functions to use objects of any of these polymorphic classes without needing to be aware of distinctions across the classes. Polymorphism has two major applications in object-oriented programming language. The first one is that an object may provide different implementations of one of its methods depending on the type of the input parameters. Now the second one is that code written for a given type of data may be used on data with a derived type, that is, methods understand the class hierarchy of a type. Now take an example of humans. We behave differently in different situations. That is, we have the same body, but it behaves differently in different scenarios. Now same is the case with polymorphism. That is, different classes may have methods with the same name, but they behave differently on execution. Well, we will look at the example right in the next slide. So now take an example of cars. Imagine that you need to write a function that calls the move forward method on any type of cars that it is passed. Every object created from the original car class or any of the subclasses that extended should have a move forward method, even if it is being overridden to do something slightly different in some of the subclasses. This means that through polymorphism, you can write a single function that takes a car object and calls move forward method. Since all the objects instantiated from the subclasses of car are still technically car objects and have all of its original properties in some form or another. So this will work. Now you can see that we have two different classes. One class is known as beer and the other class is known as dog. But they have two same methods, that is sound, and in this class dog we have the same method sound. Now this method on execution will print different things. That is, the beer will have its own sound while the dog will have its own sound. Now what we did is that we make a function make sound, and then first of all we make the objects of these classes. That is, first we make the object of the beer class, and then we make the object of the dog class, and then we make a function, and then we are passing this object to this function, and then this function, depending on the object received, called the sound method. So first of all we send this object, that is beer object, to this function, and it is received here in this object animal type, and now since beer object has the information of only the beer class method, so it will call this method sound and will print this thing out on the console screen. Now similarly we send the dog object and it will be received here in this parameter animal type, and now since we send the dog object, so the dog object has only the information of the sound which is produced by the dog class. So it is just copied here and is received here in this parameter animal type, and now this time it will call this sound method and will print this thing out on the console screen. So now coming to the advantages of polymorphism, the first advantage that we have is that method overloading allows method that perform similar or closely related function to be accessed through a common name. Now you can see that in here we are accessing both the sound method with the same object. Now this is what it is telling, that method overloading allows method that performs similar or closely related function to be accessed through a common name. That is, we are accessing basically both of these functions with the common name, that is animal type. For example, a program performs operation on an array of numbers which can be int, float or double type. Now method overloading can be implemented on constructors, allowing different ways to initialize objects of a class. This enables you to define multiple constructors for handling different types of initializations. Now method overloading is something that method overriding allows a subclass to use all the general definition that a superclass provides and add specialized definitions through overridden methods. Now method overriding works together with inheritance to enable code reuse of existing classes without the need of recompilation. So now let's move on to coding to see polymorphism in action. So for this, open your PyCharm, and now what I'm going to do is that first of all I'm going to make a class and I'm going to name it as, let's say, cat. Now this cat will have a function known as, let's say, sound, and obviously self, and then it will print the sound which is produced by cat. And now in the cat class I will have one more function of name swim, and this will print cat cannot swim. Now I will have one last method in this cat class, and I'm going to name it as color, and you can say that print. Now you can say cats comes in different colors. Now I will have one more class of name, let's say duck, and it will have the same method of sound, but this sound method will print something else, and it will print basically the sound which is produced by duck. And now we can say def swim, and we can say print duck can swim. Now I will have one last method that I also have in the cat class, and it's known as color. And now I can say print, and well, I can say duck, or you can say usually black and white. Now I'm going to make a function, and I'm going to name this function as animal properties. Well, this function is outside both of these classes, so I'm going to name it as animal properties, and this function will take an object, and now notice that this function is actually outside the class, so that is why it is not taking this object self. So it is actually taking it will actually take a parameter animal, and now through this parameter we will call these methods. So I can say animal dot sound, animal dot swim, animal dot Now I'm going to make the instances of the cat class and the duck class. So I'm going to name the first instance as catty and put it equal to the cat class obviously, and then I'm going to make one more instance for the duck class, duck class, and I'm going to name it as ducky and put it equal to a built-in class duck. And now I will pass both of these instances to this function animal properties, and it will be received in this variable, in this parameter animal. So I can say animal properties, and now I'm going to pass this function catty, and now I'm going to call this function again, and now this time I will pass this object ducky. Okay, so now what I'm doing is that first of all I made two classes, and these two classes have the same method but they behave differently on execution, and then I make a function outside the class body, and then this function is actually calling the methods of these two classes. Then I make the instance of the cat class and then the duck class, and now I'm calling this method, and first of all I am passing this object catty, and it will be received in this variable animal. And now since the catty object has all the information of the cat class, so it will call the method of the cat methods of sound, swim and color, and then I will pass this ducky object and it will be received in this variable animal. And since ducky object contains the information of only the methods that are in the ducky class, so it will go to the sound method in the duck class, and then swim method in the duck class, and similarly color method in the duck class. So now I think I can run it. So run, and it is this thing. So you can see from the output that first of all it is going to the cat class and accessing every method in the cat class, and then it is going to the duck class and accessing every method in the duck class. So this is what polymorphism is about. So let me teach this slide once again. That method overloading allows method that perform similar or closely related function to be accessed through a common name. So in here we are accessing the methods of both classes with the same name, and this name is animal. So with this animal method, so with this animal object, we are accessing the methods of both cat class and duck class. So this is what polymorphism is all about. Hey guys, and in this video we will learn one more major and most useful concept of object-oriented programming in Python, and it's called abstract classes and methods. Now first of all we will cover what is an abstract class. An abstract class can be considered a blueprint for other classes, allowing you to mandate a set of methods that must be created within any child class built from your abstract class. An abstract class contains at least one abstract method. Abstract classes may not be instantiated and require subclasses to provide implementation for abstract methods. Now remember that there is no instance of an abstract class. Now what are abstract methods? Now an abstract method is a method that is declared but contains no implementation. An abstract method is provided by the parent class, or you can say abstract class, but not implemented in the children classes. So you can see that we now have a class abcxyz, and it contains one method which is unimplemented because this method is empty and is doing nothing. So we can call this method as abstract method. Now can we create an instance of abstract class? Well, let's give it a try. So we have a class abcxyz, and it contains one unimplemented method. Now any class which contains at least one unimplemented method, then that class is also considered as an abstract class. So we have now an abstract class and we are now making its instance, and now if I run the above code, will I get any errors? Well, you will get the answer of this question in the future. So now we have a class known as math operation, and we have two methods which are unimplemented, which mean that this class is an abstract class and these two methods are abstract methods. Next, we have another class of calculate which is inheriting the abstract class math operation. And now we have in this main function, and we are creating the instance of the abstract class, and if we run the above code, it will run fine. So for classes to be abstract, it must meet the following two conditions. The user cannot be able to create its instance, and the user must implement all the unimplemented method in the class which is inheriting that class. But in the previous slide, we are creating the instance of an abstract class, and even then it is running fine. Next, in this class which is inheriting the abstract class, it does not contain the implementation of these two methods, and even then it is running fine. Well, so if these two criteria are not met, this means that this class and these two methods are not abstract. Now in Python, unlike Java or C++, Python does not provide an abstract class of its own. We have to import a module in order to make a class abstract, and another module to make a method abstract. And if we do not use this module, Python will consider abstract classes and methods as normal classes and methods. So we need to import two things from the ABC module, and ABC stands for abstract base class. The first thing we need to import from the ABC module is abstract base class in order to make a class abstract. So now in order to tell Python that we are going to make a class abstract, we need to import this thing. And now in order to tell Python that we are going to make a method abstract, we need to import abstract method from the ABC module. So from the ABC module, we are importing abstract base class and abstract method. Now by importing these two things, we can make a class and method abstract in Python, or else, as I have told you, that Python will deal these classes and methods as normal classes and methods. So we need to import ABC and abstract method from the ABC module. Now in order to make a class abstract, that class need to inherit the built-in class ABC, which is abstract base class. So first of all, we have imported the ABC module, and now we are creating a class which is inheriting the class that we have imported from the ABC module. So now by extending the ABC class from the ABC module, Python now knows that this is an abstract class, and now that Python will enforce that class to follow all the credential an abstract class need to follow. Now in order to tell Python that we are going to make an abstract method, we need a decorator for it. Well, we will cover decorator later on in the other section. So first of all, we are importing the ABC and abstract method from the ABC module. Next, we are creating a class which is inheriting this class that we have imported from the ABC module. So now Python knows that this class is now an abstract class, and now this class, which is now an abstract class, contains one unimplemented method. But now in order to tell Python that this method is an abstract method, we need this decorator before the method. So we put this @ symbol and then we type this thing that we have imported from the ABC module. Simple enough. Now let's go through an example. So first of all, we are importing these two things from the ABC module. Next, we are creating an abstract class, and this abstract class contains two unimplemented methods, which are basically an abstract methods. Next, we have a class which is inheriting the abstract class XYZ, and now this class contains the implementation of only one unimplemented method that we have in the abstract class. Now, if I create the instance of this class, because I cannot create instance of an abstract class, so I create an instance of this class and then I call this method, and now when I run this code, it will throw an error saying that cannot instantiate abstract class calculate with abstract method add. And the reason it is giving me an error is that this class, which is inheriting the abstract class, contains the implementation of only one method. Now remember that any class which inherits the abstract class, it must contain the implementation of all the unimplemented or abstract method in an abstract class. So in order to run this code successfully, we need the implementation of this method and this method in this class calculate, which is inheriting the abstract class ABC. So now that we have this class calculate and it is inheriting the abstract class XYZ, and now it contains the implementation of both of these abstract method add and mul, and now when I run it, this code will run successfully. So the rule of thumb is that any class which is inheriting the abstract class, it must implement all the unimplemented or abstract method. We must import the ABC class from the ABC module to make an abstract class in Python, and we need to import the abstract method to import or to make the method abstract in Python. Now coming to the advantages of abstract class, the first advantage that we have is that abstract classes are used to organize programs. The same program could be organized in many ways. Our example program could be written without an abstract class, but a real-world application might have hundreds of classes. Grouping classes together is important in keeping a program organized and understandable. The advantage of using an abstract class is that you can group several related classes together as siblings. And the main benefit of abstract classes, in my opinion, is if there is some code that has to be shared between classes of the same type. Sometimes the functionality of such classes may overlap and you would end up with code duplication. In this case, you can use an abstract class and just put the code there. The advantage of using an abstract class is that you can group several related classes together as siblings, as I've told you, and then grouping classes together is important in keeping a program organized and understandable. So abstract classes usually support an idea of generalization and to contribute from programmers to keep a quiet little brain discipline by designing multi-year projects, because of they, when include an abstract methods, have to be described an implementation that abstract method in sibling classes. Now, understanding the whole concept, we will look at an example. So for understanding the concept of abstract method, let's take an example of birds. Now, all types of birds share some common properties like sleeping, eating, walking, but they use these properties in different manners. Now the next question arises how they use the common properties in different manners. Let's take our first property, that is sleeping. Now some of the birds sleeps at daytime like an owl, but many of them sleeps at night. So this how they are using this behavior in two different manners. When the same functionality is found in many objects, we declare that behavior as abstract method. That is, with no implementation, so that a class extending an abstract class can provide its own implementation for these functionalities. Now to conclude this tutorial, we have learned a couple of things. The first thing that we have learned is that how can we make abstract classes and methods in Python. Next, we learned some rules that we must follow while using abstract classes and method. At the end, we learned how abstract classes can. So now you know what abstract classes and abstract methods are. Now in this video, we will make abstract classes and abstract method. So first of all, I'm going to make a class and I'm going to name it as math operation. And now this class will contain two abstract methods. So the first method will be, let's say, sum, and it will take two arguments. And since this method will be abstract, so it will only be declared, but it will contain no implementation. So we will just pass here pass. And now the next method will also be abstract, and this method will be multiply, and it will also take two arguments, and this will also be an abstract method, so it will contain only pass. So now in order to tell Python that this class is an abstract class and these methods are abstract methods, we need to import two things from the ABC module. So we can say from ABC import ABC, and this ABC stands for abstract base class, and this is for making a class abstract. So by using this class, we will make this class abstract. So now in order to make this method abstract, we need to import one more thing from the ABC module, and it is known as abstract method. Now to make this class as an abstract class using the ABC class from the ABC module, what we will do is that we will actually inherit this class right here. So we will type here ABC, and now Python knows that this class inherit this class, so this means that this class is an abstract class. And now to tell Python that these methods are also abstract, we need to use decorators. Well, we haven't covered decorator yet, but we will cover it in some other section later on in this course. But for now, just know that in order to use decorator, we use this @symbol, and then in order to make this function abstract, we will actually use this thing that we have imported. So we will type here abstract method, and now similarly to make this method abstract as well, we will do the same thing. So abstract method. So now this class is an abstract class, and an abstract class is a class which contains at least one abstract method. So now this class is an abstract class and it contains two abstract methods. Now I'm going to make one more class, and I'm going to name it as implemented class. And now this class will inherit the abstract class. And now once this class inherits the abstract class, it must implement all the methods that are abstract in this class. So let's say that this implemented class contains the implementation of only one function. So right here we will give the implementation of, let's say, sum, and we can say print a plus b. And now I'm going to make an instance of this class, because I've told you that we cannot make an instance of an abstract class. So we will make the instance of this implemented class. So I'm going to name this instance as a, and I'm going to put it equal to implemented class. And now with this instance, I'm going to call this method sum or sum, whatever. So a dot sum, and now it takes two arguments, 3 and let's say 7. And now when I run it, it should throw me an error, and you can see that it's giving me a type error and saying that cannot instantiate abstract class implemented class with abstract methods multiple. And the reason for this is that whenever a class inherits an abstract class, then that class must contain the implementation of all the abstract method that it has inherited. But in our case, we are only implementing this function. Now when Now when I implement this function as well and then run it, so first let's implement it. So def multiply, and then let's say print a multiply by b, and now with this instance I'm going to call this method as well. So it takes two arguments, let's say it is 7, 3 and 7, and now when I run it, so now it is working fine. So let me explain it one last time. So first of all, I have made a class which is actually inheriting this class that we've imported from the ABC module, and by inheriting it, Python comes to know that this class is gonna be an abstract class. And now similarly, in order to make this method abstract as well, what we did is that we make use of decorators, and to use decorator we put this @ symbol, and then we use this thing that we have imported. So now Python also knows that these methods are also abstract. Now we made one more class, implemented class, which inherit the abstract class, and whenever a class inherits an abstract class, it must give the implementation of all the methods that are abstract in the inherited class, or else it will throw an error. So we give the implementation of these to unimplemented method in the abstract class, and then we just simply call it by making the instance of the implemented class. And then when I run it, it shows me the result, it shows me the right result.
Hey guys, what's up? And I welcome you to another tutorial on object-oriented programming in Python. In this tutorial, we are going to be covering a very interesting concept in object-oriented programming, that is the instance methods, the static methods, and the class methods. I'm going to be explaining each one of these with examples one by one. So let's start on with the very first one, that is the instance methods. Instance methods are the most common type of methods that are used in the Python classes. They are so called because they can access unique data of their instances, or you may say objects. If you have two instances or objects, each created from the very same class, then they each may have different properties. They may have different attributes, different, you may say anything. For example, if you consider the example of a house, then one object might refer to the size of the building, the other object may define the color that is on the walls, the third object or the third instance may refer to the doors installed in the houses, and so on. One thing you must know about instant method is that instant method must have a self as a parameter, but you don't need to pass this in every time. Self is another Python special term which you might have covered in the previous tutorials. Inside any instant method, you can use self to access any data or method that may reside in your class. You won't be able to access them without going through self. Finally, as instant methods are the most common, there is no decorator needed for them. Any method you create will automatically be created as an instant method unless and until you tell the Python otherwise. So let me give you a very quick example and a very good example that will, I hope, clear each and every of your doubts relating to instant methods. So the only thing you need to know about instant method is that you have to specify the keyword self in the class as well as the functions. So let's start on with an example. So let's move on to PyCharm. So first we will define a class named, let's say, since we are talking about instances, so let's define a class named instances and a colon. And the first thing we need to do about this is that we need to define a constructor function in which we are going to define an object. The self object right in here was automatically added. I don't need to add it. So now what here I'm going to do is that I'm going to first print out I am the constructor function.
And I'm going to add one more statement to make the thing look what actually is going on. So it's going to, this constructor function, whenever called, it's going to say that I'm the constructor function. Anything initialized using me have to be initialized using the self keyword. So I hope this is clear. Anything you are going to initialize in this constructor function is going to be initialized using this self keyword. So now I'm going to initialize something. Let's initialize my name. So I'm going to write in self.name equal to Omer Khan. So let's move out of this constructor function. So now I'm going to define an instance method. So what is an instance method? So let's name it as instance method. It is not something that is by default here. You can name it anything, and you can automatically see that self was automatically added right here. So now what I'm going to do is that I'm going to first print out, and it's going to say I am the instance method. Because why this is an instance method? Because we have added this self right here, and anything we want to print from here, for example, if I want to use this name right here, then I'm going to specify this using the self object, or you may say the self keyword. So I'm going to write in print out my name is the concatenation sign, and then I'm going to write in self.name. So if I just move out of this body and create an object of this class name instance, and then I'm going to write in object dot the name of this function, that is the instant method. So I will just copy this, paste it right here, and that's okay. So let me just run it, and then I'll explain what's going on. So I have my output, just scroll down. So first it says that I'm the constructor function. Then secondly it says that anything initialized using me have to be initialized using the self keyword. And thirdly it says I'm the instance method, and it says my name is Umair Khan. So what's going on in here? When I define this object and make it equal to instance, the constructor function was called automatically. Anything in the constructor function, if was in the print statement, it was printed on to the console screen. As you can see, these two statements right here, these two statements which were printed because we have these two print statements right here, and we have this text right in these print statements. So these were by default, or you may say as it is printed onto the console screen. The third thing is that I have initialized something named self.name equals to Umair Khan. If I just remove this self from here, and now I run this code, you can see that I have a lot of errors because it says name was not recognized, because it don't know what is name. Because you can see right here that it has printed things up till I am the instance method, that is up till here, but when this statement was executed and self.name was present here, it did not recognize it, because this self is very important, because this is an instance method, and for an instance method you need to keep this, encapsulate this thing in your mind, that you always have to specify this self when initializing any variable, when initializing any function right here. For example, if I just remove this from here, and you can I don't need to run it, you can automatically see that I have this error right here. So I have to specify this self here. And if I just remove this self from here as well, now I just run this code, you can see that I still have errors because it did not recognize this name. So I have to specify the self.name with this. So if I just run this code now, you can see that it executed perfectly, because when using this object I call this instance method, this instance method was called, it printed out I'm the instance method, and it printed out my name is self.name. It used this object, and since this object refers to this constructor function for now, and this has this variable self.name, so this self.name was accessed in here from here using this instance method, one call using this object from here, and all these things were just printed out here. So the name variable is accessed through self. Notice that when this instance method function is called, you don't have to pass self in Python right here, because you can see that I haven't written self here because it is going to generate because the compiler also has to do something. We have to make the compiler, our compiler is intelligent enough to add this self automatically here. The Python compiler does it for you. It pass in self, make the initializations, and anything then initialized using the self is going to be printed out. So I hope this is clear that what is the instance method. In the instance method, all you need to do is that any initialization you want to do is going to be done using the self keyword. Any function you want to initialize, you have to specify that self in here, and anything you want to access from this constructor function. For example, I have written self.name equal to marathon. So when I want to access this name, I have to specify the self dot here, which is actually this object that grab every data from this constructor function from here. So I hope that instance function is now clear. So moving on to the next method that we have, what was the name of that? Yes, the second is the static method. So to explain static methods are methods that are related to a class in some way, but they don't need to access any class specific data. You don't have to use the keyword self, and you don't even need to instantiate an instance. You can simply call your method. So to explain static method, you can just add certain amendments in this code. You can just remove this from here. You can remove this data right in from here, and you can just remove this statement from here as well. I think that's perfect. So if I just run this code, alright, it's generating some errors. So what does the error says? It says that instant method takes 0 position but 1 was given, object.instant method in line number 10, and it says I'm the constructor function. Alright, I have spotted the error. Yes, I've spotted the error. What you need to do in here is that this method, the first thing you need to do is that this method need to be called automatically, because since we have not specified any kind of self.things in here, so you don't have to be calling this. And secondly, you have to just write in, it is not the instance method anymore, it is the static method, and it's also going to say I'm the static method. It's not going to store the identity of another method, so a static method here as well, and it's going to work perfectly. I think now, yes, it worked perfectly, and it says I'm the static method. Now you might be confused that why this was not printed, that I'm the constructor function. This is the only ability of, or you may say the part, or you may say the feature of a static method, that a static method is called independently. It doesn't bother whether a constructor function exists or not. It's not going to be called using the object. It's going to store something in the object, but it's going to be called using the instances class, and we're going to write an instances.static method directly. We are not going to be using this object because it's going to give us error, because since when the constructor function is called, in this case, when we write in here that object equal to instances, let me just specify it down here so that we can easily remove it, instances, and then we specify object dot static method and underscore right here. So in this case, an object of the instance method is created and this constructor function is called. Once this constructor function is called,
and after that we call this, then we have to specify this self here. If you don't specify this self here and make it an instance function, because when we call a method using an object, then that is actually calling an instance method, not a static method. When we are calling an instant method, when we are calling a static method, we don't have to specify an object. Very simple scenario. In this case, as you can clearly see, that we have this object right here, and then using that object, or you may say instance, we are calling the static method. Using an object and calling a static method seems to be a very stupid thing. It's a very simple thing. Using an instance, don't call a static method. Call a static method just like this, to be very simple. When you are using an instance and calling a static method, then it's not calling a static method, it's actually calling a method that is an instance method. For example, if I just remove this from here and I run this now, it executed perfectly and it says I'm the constructor function, it says I'm the static function, but it's not a static function because I have specified this self right here. So all I need to do is press Ctrl Z twice, remove this from here, remove this from here as well. Now run this code and it's going to say I'm the static method, because static method is a method that is going to be called independently. The static method decorator was used to tell Python that this method is a static method. The static methods are great for utility functions which perform a task in isolation. They don't need to access the class data. They should be completely self-contained, or you may say self-oriented, or you may say completely independent, and they should only work with data passed in as arguments. You may use a static method to add two numbers together or print a given string. For example, in this case, if I want to pass something like in the previous case I printed out the name, and in this case I want to pass in the name, I have to pass in from here. For example, if I just pass in a string here, named Omer, name a variable here, name, and then print out and say simply name, run this code, you can see right here that it says I'm the static method and then it says Omer. So in the previous case you have to use the self object to access something that was initialized in this constructor function, but in this case, since we are dealing with a static method, and for the explanation of static method I told you that a static method is the method that is self-contained, or you may say is an independent method. So you don't have to deal with the constructor function. If you want to initialize some variable, you have to pass that variable as an argument to the static method. So I hope this is clear. So the next method was, the next method was the class method. Not thank you for now. The next method was the class method. So what are class methods? Let's move on to PyCharm. So what is a class method? A class method are the third and final object-oriented program method type to know. Class method know about their class. They know that which class I belong to, which in case of static methods don't know which class they belong to. They are going to just simply perform a task. Since they are self-contained, independent, they're going to perform the task. They don't know which class they are dealing with, but the class method know about their class. The instant method also know about their class. So for the explanation of class methods now, class methods know about their class. They can't access specific instance data, but they can call other static method. For example, if we have a static method in a function, in a class, and then we have a class method as well, then using the class method we can simply call a static method. So class method don't need self as an argument. They do need a parameter called CLS to make them a class method, as in the case of the instant method you have to specify self name self so that it is the instance method. In case of static method you don't need to specify anything, and in case of class method, in the method you want to make a class method, you have to specify CLS, that stands for class. So class method are created using a simple, you can create them using something called decorators, but that is not something that is always required. So we already have a constructor function, we already have a static method.
all we need to do is make certain additions to this code to make the concept of class method clear. So I'm going to make a function name class method, and this class method is not going to have self, it's going to have CLS, so that it is a class method. So now you can simply see the distinction right in here. This constructor function has the self, this class method has this CLS, this static method has something we have passed in as argument, we can just leave it as empty, and for the instance method we also have to specify the self. So now to this class method, we have to call this static method using this class method. So what I'm going to do here is that I'm going to use this CLS object. So I'm going to write in CLS dot the name of this method I want to call, that is the static method. So I'm going to just Control V this, let me just remove this for now, and I'm going to pass in my name as well. Good enough. And now down here outside this class, what I need to do is that I need to create an object of this instances class, and using that object now, or you may say instance, what I'm going to do is that I am going to call this class method. So I'm going to just copy this, paste it right here, and this code is going to now run perfectly, I think. No? It's very sad. Alright, so what does the error say? It says that static method takes one positional argument with two are given. Moreover, it says we have error in this CLS the static method as well, and then we have errors in object.class method as well. So what can be the possible problem? Yep, I've got it. It says static method takes one positional argument but two are given, which means that it is not recognizing a static method or a class method. So all you need to do is that you need to specify, but first let's specify a print statement right here that says I am the class method. Alright, all we need to do now is that we need to add @ and tell it that it's a class method. This is actually a decorator which you are going to cover in very detail in the future. We have a very special and separate section on this very topic named decorators. In that you will study in very detail about this. All you need for now is that whenever you are going to specify a class method or a static method, then you have to specify @ class method. You can't use any word of your own choice. You have to specify this very word named class method right here and this very word named static method right here. And now if I just run this code, you can see that it's ran perfectly. The first thing it executed was I'm the constructor function, because the first thing we have done here is that we have created an object, and when creating an object we have called the instance for the constructor function. So anything in the constructor function, the block of constructor function is going to be executed, and it says I am the constructor function. Secondly, we have called the class method, and it says I am the class method. Right here you can see that the second statement that was executed was, it says that I'm the class method. Then it passed in this omer to this static method. This was a static method. It was recognized using this decorator, and it printed out I am the static method. You can see right here the third statement is I am the static method, and the fourth thing was it printed out my name. So I hope that it is clear that what is the purpose of class method now. Class method is going to call a static method from within him. So I hope that's clear, and I hope that you very well know the difference between an instance method, static method, and a class method now.